We shall now move on to our second topic. That is, geometrical meaning of the zeros of a polynomial. Let us learn about the importance of zeros of polynomials using geometrical representation. To understand the importance of zeros of polynomials, we take the help of geometrical representation of the polynomial on the graph for linear polynomial, quadratic polynomial, and cubic polynomial. Now let's discuss about geometrical representation of the polynomial on the graph for linear polynomials. Consider a linear polynomial ax plus b. A is not equal to 0. And we know that y equals ax plus b is a straight line. For example, the graph of y equals 2x plus 3 is a straight line passing through the points -2, -1, and 2, 7. Alternatively, we can get y coordinate points if we know x coordinate points. Suppose take x points from -2, 2. And when we put x equals -2 in the equation, that is, y equals 2x plus 3, then we get y equals 2 into -2 plus 3, which is equal to -4 plus 3, that is equal to -1. Similarly, when we put x equals 2, then we get y equals 2 into 2 plus 3. This implies 4 plus 3 equals 7. Finally, we got x and y coordinate points as -2, -1, 2, 7, respectively. From the above points, the table would look like this. From the above x and y coordinates, let's plot the graph. Here arrows indicates that line intersects the x-axis midway between x equals -1 and x equals -2. Finally, from the graph you can observe that y equals 2x plus 3 intersects the x-axis midway between x equals -1 and x equals -2, that is, at the point -3 divided by 2, 0. By this we will know that this point is also the zero of the polynomial. Let's find out the zero of the polynomial. Zero of the linear polynomial p of x is p of k equals 0. That is, if k is a zero of p of x equals 2x plus 3, then p of k equals 0, which gives us 2k plus 3 equals 0. This implies that 2k equals -3, which again implies that k equals -3 divided by 2. Thus, the zero of the polynomial 2x plus 3 is the x-coordinate of the point where the graph of y equals 2x plus 3 intersects the x-axis. Now let's generalize the meaning of zero of polynomial. For a linear polynomial ax plus b, a is not equal to 0, the graph of y equals ax plus b is a straight line, which intersects the x-axis at exactly one point, namely, -b divided by a, 0. Therefore, the linear polynomial ax plus b, I is not equal to 0, has exactly one zero, namely, the x-coordinate of the point where the graph of y equals ax plus b intersects the x-axis. Now let's discuss about geometrical representation of the polynomial on the graph for quadratic polynomials. To find the zeros of the quadratic polynomial, let's try to explain with an example. Now let us note that, if we know the x-coordinate values, then, alternatively we get the y-coordinate values, while substituting x value in equation. Consider the equation, y equals x square minus 3x minus 4. Substitute x equals -2, we get y equals -2 whole square minus 3 into -2 minus 4. By cancelling negative and positive value, we get